Let's understand homogeneous differential equations with a couple of more examples. So suppose I have a function here. I have an equation here, x times cos y by x dy by dx, and y equals to y cos of y by x plus x. Is this homogeneous? First of all, we have to work on that, and then we have to solve it. So clearly, see, if you will take everything to one side, find out dy by dx. dy by dx is turning out to be y times cos y by x plus x upon x times cos y by x. Now, this is of the form that dy by dx is equal to f of xy. This is of the form that dy by dx is equal to f of xy. If we will input, instead of xy, we will put the input lambda times x and lambda times y. If you notice what will happen, lambda comes out common. So it is lambda upon lambda. And here you have y cos y by x plus x, whole thing upon x times cos y by x. Lambda, lambda cancels. And if you notice, you do have fxy itself. So that means this is homogeneous. This function is homogeneous of degree 0, which means it's a homogeneous differential equation. Yes, it's a homogeneous differential equation. Let's solve it. Clearly, I can see y by x here a lot many times. So I'll take y by x as v. Let's take y by x as v. Let's take y by x as v, and that will give me dy by dx is equal to x time is equal to v plus x times dv by dx. So in place of dy by dx, we will write v plus x times dv by dx. After doing that, what will we do? We will convert everything in terms of v and dv by dx. So x and v. So we have here v plus 1 upon cos v, v plus 1 upon cos v is equal to v plus x dv by dx. So what's happening here is, see, if you notice here, it's y by x. So this is v. Let's just divide basically, you can divide. You will get y by x plus cos y by x cancels. So you will just get y by x from here, and here x cancels, and you will get 1 upon cos y by x. Y by x is v, so hence you get this expression. So v plus 1 upon cos v equals to v plus x dv by dx. Which means if I take everything to one side, taking the LCM, I'm going to get v cos v plus 1 upon cos v and minus v. Here, minus v is equal to x times dv by dx. So what I'm going to do here is, I am going to again take the LCM. So we have v cos v plus 1 minus v cos v. V cos v cancels. Or in other words, I could have done that before also. V cancels basically. So you have 1 upon cos v equals to x dv by dx. So what we will do, we will separate. Okay, it's a separable form. So integral of cos v dv is equal to 1 upon x, integral of 1 upon x dx. So integral of cos v is just sine v. So sine v equals to log of mod x plus log c, or in since here you have log of mod x, so that's why we have taken plus log of c, mod c, and that would give that you can write it down as a product. So sine v equals to log cx. Now you can convert everything to x and y. So y by x equals to v, which means that y equals to vx. And hence what you have basically you have sine y by x equals to log of cx. That's the solution to the given differential equation. Let's also take another example of homogeneous equations only, differential equations. So is 2y e to the power x by y dx plus y minus 2 times x e to the power x by y dy equal to 0 a homogeneous equation? Is this a homogeneous equation? Solve it for general and particular solution. Particulars for particular solution, use x equals to 0, y equals to 1. So let's check homogeneity. So what we will do, we will first create dy by dx. So dy by dx is clearly 2x, taking everything to one side basically. So it's 2x e to the power x by y minus y upon 2y e to the power x by y. And this is clearly a function of x and y. To check homogeneity, let's input x in place of x, let's input lambda times x. In place of y, let's input lambda times y. So this is equal to twice of lambda x e to the power x by y minus lambda y upon twice of lambda y e to the power x by y. So this gives you, you can check for yourself, see lambda cancels. So 2 lambda, I'll just take lambda here, and here what you will get 2x e to the power x by y minus y upon y e to the power x by y. Well, that's what is your fxy. So this turns out to be just fxy, or this is homogeneous of degree 0, which means it's a homogeneous differential equation. Now here I can see x by y in a lot of terms. So we will this time take v equals to x by y. Let's take v equals to x by y, and x will be equal to v times y. Therefore, when you will differentiate with respect to y, so you will get dx by dy equals to product rule here. So v as it is, v basically derivative of y, which will give you 1 plus y derivative of v with respect to x. So hence you get this expression. So in place of dx by dy, what you can do is you can just write it in terms of dx by dy. I had written it in terms of dx by dy only. So dx by dy, in place of that, just write what the expression that you are getting equal to what you get dx, or what you got dx by dy as. So 2x e to the power x by y minus y upon 2y e to the power x by y equals to v plus y dv by dy. And now, of course, it will be in terms of converted to v and y. So in terms of v and y, your equation will be so let's just divide this. When this gets divided, you will just have x by y term left minus y cancels 1 upon 2 e to the power x by y. Now that means you have v minus x by y is v, so v minus 1 upon 2 e to the power v minus v. So v cancels, and what are we left with? We're left with 1 upon 2, or 1 upon 2 minus 1 upon 2 e to the power v is equal to y dv by dy. So let's separate v terms and y terms. And what you will have the 2 ev dv is equal to minus dy by y. So you will integrate on both the sides. Just integrate on both the sides. When you will integrate on both the sides, you will get the solution. So integrating on both the sides, you will get 2 e to the power v is equal to minus log mod y plus c. Since you have e here, so I'm taking log to the other side. So this side only. So it's basically 2 times e to the power x by y plus log mod y equals to c. Now this is what you get for your c. for particular solution, this is your general solution. Now you have C. Put the value x equals to 0 and y equals to 1. Put the value x equals to 0, y equals to 1. When x is 0, y 1. If that's happening, you will get 2. E to the power 0 is 1. So just 2 here plus log 1 equals to C. That means C is equal to 2. If C is equals to 2, that means your particular solution is 2 e to the power x by y plus log mod y is equal to 2. So this becomes your particular solution where C is a particular value 2. Okay. So we've done this question, which was in terms of x by y. So yes, you can have a case of y by x as well as x by y. Make a conversion the way we do. X by y, take it as v, or y by x, take it that as v, in case you have a homogeneous system or a homogeneous differential equation. Show that the family of curves for which the slope of the tangent at any point x comma y on it is x square plus y square upon 2xy is given by x squared minus y square equals to cx. Okay, so if the tangent at any point xy, that is dy by dx, is x squared plus y squared upon 2xy, so this is what I have for dy by dx. So tangent means dy by dx, so slope of the tangent. So if this is what I have, that means dy by dx is a function of x and y. That means dy by dx is a function of x and y. Is it homogeneous? Well, I can actually just see right through because the power is 2 to 2. So therefore, when you will be putting lambda x, lambda y, when you will put lambda x, lambda y in place of xy, lambdas will cancel, and yes, you will get fxy only. So this is homogeneous of degree 0. That means it's a homogeneous differential equation. Now let's follow what we do in homogeneous differential equation. So dy by dx is equal to, what we can do is we can take x square common. So 1 plus y by x square. This will become 1 plus y by x square. So what we've done is we've taken x square common here also and here also. So here in the denominator, it will become 2y by x, because when you will now multiply by x square, you will get xy. So this is what is happening. So this is cancelled. So this is what you have. Now you can put y by x as v, and you know that dy by dx will be equal to v plus dx dv by x times dv by dx. Substitute for dy by dx in the equation that you have. Substitute for dy by dx in the equation that you have. Hence, what you will have to solve for is right here, that 1 plus v square upon 2v is equal to v plus x times dv by dx. V goes to the other side and solving it. V goes to the other side, solving it, you will get 1 plus v square minus 2v square after taking the LCM upon 2v is equal to x dv by dx. So that means 1 minus v square upon 2v is equal to x times dv by dx. All v terms on one side, all x terms on the other sides, and integrate. So you have 2v upon 1 minus v square dv is equal to dx by x, taking the integral. So now you have to integrate this. Integrating this. Now, I'm going to change the sign first of all. See, I know that 2v is the derivative of v square. So what I'm going to do is, to make my life simpler, I'm going to take minus sign common. So, or in other words, I'm going to multiply both the sides by -1. So here you have a minus sign now. And here you have v square minus v. Instead of 1 minus v square, you have v square minus v. V square minus 1. V square minus 1. So now you can substitute, make a substitution, take v square minus 1 as, you can take it as t. So 2v dv is equal to dt. And hence, when you will integrate, what will you get? This turns into integral integral dt by t. So you will just get log of t, which is basically mod log of mod t, which basically means for t, just write down v square minus 1. So it's log of mod of v square minus 1 equal to minus log mod x plus log c dash I'm taking so that, later on I can just convert. So log v square minus 1 plus, I'm taking all the logs on this on the on same side, because since you have log on both the sides, so you can use the product thing. So this will become, since you have log on both the sides, so that you can take the product thing. So this becomes log of x mod of x times v square minus 1 is equal to log of c dash mod c dash. So that means, since you have mod here, that means c dash could be plus minus of this value, x of v square minus 1. Okay. So now we can, have a common c as a constant. So this becomes, after substitution, you will have to substitute. So when you will substitute, what will happen here? If you substitute, so you have x and you have y square by x square minus 1. So this will give you x, y square minus x square upon x. So x square, so one of these cancel. One of these cancels. And what you get is that your c, y square minus x square is equal to plus minus c dash x, or you can now, instead of c dash, I'm just taking another constant which will satisfy this condition. So x square minus y square is equal to cx. And this is what we wanted to actually prove in this question. This is what was demanded out of you. They had said that prove that or show that family of curves for which the slope of tangent, that is dy by dx, is x square plus y square on 2xy is given by x square minus y square equals to cx. And yes, this is what we turns out to be our solution as well, right?